microclimate and outdoor conditions and their influence upon designing the indoor microclimate. The biggest factor in climate forming is our sun, which is the star in the center of our solar system. It is enormous and radiates huge amount of heat, and what reaches the surfaces of the earth is less than 1/10 of the percent of what was radiated from the sun's surface. However, it is completely enough to trigger all the processes, the atmospheric processes, and all the climate changes, and to support all the life on the earth we know. There are three factors that influence the forming of the climate changes on Earth. The first is that the Earth circles around the Sun in an ellipse, not in a complete circle, and that the Sun is not exactly in the center of that ellipse, but slightly tilted to one side. The second factor is that the axis of the Earth is inclined towards the plane in which the Earth circles around the Sun. And the third factor is the form of the Earth, which is not exactly spheric. It's something called geoid. It's a little squeezed at the poles. So when the northern hemisphere is inclined away from the Sun, and it's winter in the northern hemisphere, but it's summer in the southern, the Earth is closest to the Sun. Then we have the middle seasons, the spring and the autumn, and when the northern hemisphere is inclined towards the Sun and we have summer, and there is winter in the southern hemisphere, the Earth is the furthest away from the Sun, which means that in northern hemisphere we have milder winters and cooler summers compared to the same seasons in the southern hemisphere. The geoid form of the Earth means that the almost parallel sun rays that reach the Earth are not distributed evenly upon the surface. They meet the surface in different angles, and that means that their energy is in different ways absorbed by the Earth's surface in the oceans. The Sun radiates all the waves we know so far, from gamma rays up to extra long radio waves. And what is in the area of radio waves is called white noise. So the Sun can be heard with some technique help. The gamma rays, the X-rays, and the bigger part of the ultraviolet rays don't reach the surface of the Earth because of the atmosphere. They have too high vibration, so they distract easily and get reflected back into the space. From the overall radiation of the Sun, what we can accept with our visual sender is called visible light, and it's a very small amount of overall sunlight radiation. Then come after the visible light come ultraviolet rays, which are short wave, medium wave, and long wave ultraviolet, then microwave and radio wave. The kind of waves that are responsible for the heating of the solid and liquid objects on the Earth's surface are about 50% the infrared light, almost 50% the visible light, and a small amount of ultraviolet rays. So, because of the atmosphere, what reaches the upper layer of the atmosphere is not what reaches the Earth's surface, and it's distracted due to different processes going in the atmosphere almost by 50% until it reaches the Earth's surface, and there it's transformed from electromagnetic energy into heat energy and stored there, and then radiated back in the colder periods. Again, what is radiated back is reflected back or distracted in some ways, so not the all amount of heat energy radiated by the Earth's surface does not reach deeper layers of the atmosphere. So, the role of the sunlight for the building functionings and energy efficiency. The sunlight provides the necessary amount for heat comfort, light comfort, and physiological comfort connected with the regime of sleep and awakeness. The human beings need some regime of natural sunlight and darkness in order to have a proper regime of awakeness and sleeping. What we need to control in buildings is the amount of solar radiation in order to reduce the overheating and the heat gains, to reduce the seeing tiredness because of too much sparkles and too bright light coming into the eyes, and to prevent the materials aging. Solar radiation is usually not evenly distributed on the surface, not only because of the form of the Earth, but also because of the local relief, mountains, plains, forests, rivers, and seas and other water basins. So, for example, Bulgaria has three major areas with different quantity of different amount of solar radiation gained through the year. The other major group of processes following the triggered by the solar radiation turned into heat is are the processes including water. So is the humidity of the air, which is seen as mist, clouds, and of course rainings, and it varies according to seasons, according to places on the earth. And we need to control as most as more as possible the humidity of the air in order to reduce the temperatures, to prevent the materials from destruction because of washing away some of the minerals of the materials, and also to ensure a physiological comfort, because too much humidity causes difference, causes struggling with breathing, and also creates conditions for growing some mosses and other not healthy processes. Again, there are different distribution of amount of rainings and amount of uh, water processes and moisture according to the local relief. Also, the difference in temperatures in different places of the earth causes different air pressure. The air pressure is the amount of air that is pressuring 1 square meter of the Earth's surface, and it is estimated about 7 tons per square meter. Each one of us is wearing 7 tons of air on his shoulders, and of course we don't feel that because of the inner blood pressure that compensates. However, the difference in air pressures on different places causes the movement of air. The movement of air causes is the reason for additional cooling, for bringing rainings or too much heat, and it's again a seasonal and non-constant happening.